Welcome back, everybody. We're going to be looking at where we left off last week, which is we were working on the functions playground here in let's call it Unit 2. And we ran out of time, and normally we would have coded through the last couple of pages here, but I left it as kind of a challenge to see what you guys can come up with. You will see here, we're looking at one of the students' screens, and Jomar, thank you for sharing. And Jomar, you managed to get the first part of this, but are kind of stuck on the second part. So we'll look at the first part and see what you did right or wrong, kind of review the whole concept here, and then we'll together write the second part, and then we'll move on to the next thing. So first of all, let's talk about what the instructions are here, because they're showing basically this directive basically to write a function called greeting that takes a string argument called name, and they're telling us what to name things. They're telling us the data types here, and then also that it returns a string that was passed into the function. So if you pass in Dan, the return value might be, "Hi Dan, how are you?" And then use the function and print the results. In other words, don't just create the function, call it also and utilize it. And I'm not sure if you guys are seeing my annotation toolbar here, but for me, it's like overlapping the content of the screen. So I'm trying to get it out of the way, and it's just not cooperating. All right. Anyhow, if we look at this particular function, you did a great job, Jomar, of naming it and putting it together. So it says func greeting, which is what we were told to name it, a set of parentheses. That's pretty standard too. If there are any values to pass in, right, they go inside those parentheses, and you can see this part of it here is the name of the variable, then the colon, right, and I'm sorry, my little name keeps popping up in the way there, and then the data type of that variable. So that would be the string, right? So name colon of data type string. Now, where I caution you on this, right? Because I know like at least one of you is like currently also taking Java. And when we do Java, the order is different, right? So we put the data type first and then the variable name. We do know also, and I'm just kind of doing this as a sideline, that generally Swift is a strongly typed language, but it sometimes operates in a loose fashion just the same way Python does, where you just like throw a number in a variable, then it figures out, oh, I'm an integer, just figures it out automatically. The fact that we're strongly typing things is an indicator of the power of the language, though, generally speaking. So it is, always preferred if you can declare your data types to do so, because it helps with memory management largely. The other little piece here that we look at is this dash greater than symbol, which we call a lambda expression, right? And you'll see this in other languages too. But in this format, Apple's using it to indicate that when we have this function, the lambda expression, the dash greater than, is an indicator that we're returning something, and then the data type of whatever we're returning. What we're returning doesn't need to match what's being sent in. In this case, it does, but it doesn't have to. So keep that in mind. If you have the lambda expression, that dash greater than, then you will have to have a return statement somewhere inside that code, usually at the bottom, but it can be in other spots too. All right, so this is put together nicely. You went right to the return code here. You use string interpolation, and then you also called the function indirectly, right, by printing it. So you issued the print command, and then you called the function and sent in the value Dan. That's received here in this spot. It propagates in through string interpolation, and then it outputs to the screen. And you can see in the sidebar there and in the console at the bottom that it worked just fine. All right, so Jomar, it's the second part that you didn't get. So let's read the instructions, and I'm going to have you code this, right? So you're going to be steering the ship on this. It says write a function that takes in 2 int arguments and returns an int. The function should multiply the two arguments, add two, and then return the result. So it's a very specific set of math, not hard, but specific. Then use the function, right, which means call it somehow and print the result. So let's take each of these things piece by piece. So we're not told, right, what to name it, right? So that's one little thing that might have like put a damper in your progress. But let's just come up with a name, because basically what we're going to do is it's multiplying and then adding. So you can call it anything like that. What the author called it is almost multiplication. So why don't you go ahead, create a func, and then call it almost multiplication. Yeah, and don't worry, this is not an English class.
Yeah.
So if you don't spell it exactly correct, not a problem. But you are missing an I after the PL. Oh, right after the L, not before. All right. Now we're going to need a set of parentheses after this, right? And what I recommend is that the parentheses ideally should touch. And then what I like to do is right away, I type in the opening curly bracket and press enter just so it locks in. And more importantly, so I don't forget to type in the closing curly bracket. All right. Now inside the parentheses, we're told that it takes two integer arguments. And so we need a couple of variables here. Here's what I would suggest. How about let's call the first integer the first number. So you can call it first num or first number, one of those. All right. Then a colon, and then the data type, which is, of course, an integer. And then a comma. And then let's do a second one with the same naming. So first number, second number. Bleeding on like my Java habits, I might call it like num1 and num2. That works just fine. It doesn't really matter. Now we also need to designate a return type. So if you look at the syntax that you use up above on line 6, here I would insert the lambda expression, which is the dash greater than, and then what type of data we're returning, which once again is an integer. And I see you're very intuitively typing it. Now, like the previous function, we can go directly to a return statement, and that's what I would recommend here. So type the keyword return, and I think you might be able to do the rest yourself, but basically we're going to multiply the two numbers together. So we'll take the names that we designated on line 11 and just multiply them. Yeah, not using the function though, not at this point. So if you're just doing that to grab the variable names, that's a really long-winded way to do it. You're better off just trying to let the IntelliSense do it for you. So just type the letter F and wait, there you go. So first num, and then I do space star space for the multiplication. Then of course, second number, right? And then we want to add 2 to it. So space plus space 2. All right, so there it is called. Now to make it function, and this is this is where it gets a little bit weird, right? Because normally what you did above where you printed it, and inside there you called the function and sent the data, and you can do it that way. That's absolutely fine, but consider a different way. Let's add a blank line down here, and let's set a variable, and let's call it almost multiplied. So call it let, and actually not a variable. Let's make it a constant. That's the Swifty way to do things, right? So do a let statement, a space, and then almost multiply. And so what we're going to do is we're going to call the function and then store the value here and then output the value. All right. And then put in an equal sign. And now call the function and send in a couple of values. But what I want you to do is like carefully use the IntelliSense here to guide your pathway. So just start typing almost and see how it found the function. So just press enter, and int is highlighted. So we're going to let it guide us. So just type a number. What the author used as number was the number 8, and then put in a different number there. And normally, just a handy tip, I would use numbers that are really easy to verify that they work correctly, but we'll trust. Yeah, there you go. Those will be a little bit easier to verify. All right, so now we're calling it, we're sending it 2 values. A value comes back to the right side of that equal sign, and then will get stored in the constant that we created called let almost multiply. Now we just need to put it on the screen. So add a line below that and just print that variable, or excuse me, constant. All right. And without having to hit a run button or anything, you can see that it's 38. 9 times 4 is 36 plus 2 is 38. So it is the right answer. But that's the answer to that one. So there we go. All right. Why don't we move on to the next one? And if Jomar, since you're being such a good sport about this, let's take a look at this next one and see if it's something that you might want to do. Did you actually do this one?
I did have to go back a few times, and I did use a cheat sheet, the teacher edition, but yeah.
Okay. But that's okay. That's exactly why the teacher edition is there, real frankly. And what we're doing here is we are kind of following on this pathway of the fitness tracking app, whether you like that paradigm or not. The one thing that I might ask you to do here, because this code's slightly more complex, can you do Command plus and zoom in just a couple clicks? Just to make your font a little bigger. There you go. Thank you.
Mhm.
All right. So let's read through here. It says one principle that can help in debugging and maintaining code is abstraction. And this is an important concept, you guys, this whole concept of abstraction. So for example, in your fitness tracking app, some of your existing functions have been written to both perform a calculation and print a message. But it's very possible that you'll decide to change either the calculation or the message in the future. So it's easier to go back and change stuff if you keep these things separate. So in other words, if you separate the calculation from the message. So as an example, write a function that only does a portion of what your previous pacing function did. So it says this function will be called calculate pace. It should take 3 double arguments, and they give you the names current, total, and total distance, and then current time. And then it should return a double that will represent the time at which the user will finish the run based on the user's current distance and time. Call the function and print the return value. So that's part 1. So let's just take a look at what you did here. I'm going to pull out my little Zoom annotation tools here and start looking at what you did here. So you named it calculate pace, which is what you were told to name it. So that's this part. You're passing in 3 doubles. So I see 1, 2, 3 doubles. And you're returning a double. So that all looks good. You were told to pass in the current distance, the total distance, and the current time. Those all look good. So when we call this, we have to send in 3 values, all of them doubles, right? And then in order to do the calculation, and I'm going to assume, you looked at our previous calculation to figure this out, right?
Yeah.
Right. So you didn't have to like come up with it from scratch. Not that you couldn't figure it out here, if it really came down to it. But basically, we're just taking the current time and then dividing that by the result of the current distance divided by the total distance. And then that gives you a percentage, basically. And we assume the calculation is correct, right? So we're taking that on faith because it's already been done. The next thing, and I see that you did that, kind of the approach we just used at the end of the last slide, is you did set up a variable that now is going to call the function, send in 3 values, and then store the result. And this is a really common approach, right? call a function, and whenever you call a function that has a return value, that value has to have somewhere to go when it gets back. And this is really why I like teaching storing the return of a function in a variable, because then you see it rather than just putting it in a print statement. Now you could put this directly in a print statement and it would work, right? But this allows you to separate the two pieces. Now, if you were looking for memory efficiency, I suppose you might omit the let statement and just put it right on the screen. That would work on a simple program. But if you consider that this would be a more complex program where we need that piece of data for something else, that would be relevant to store. So that's another reason to do it that way. But I like what you have here. This looks good. The first part looks great. All right, let's read the second part. The second part says, now write a function called pacing that takes 4 double arguments, and that it reiterates them again. So it's the same ones, and then a separate one for goal time, right? So we're just adding one. And then that should return a string, not a double, but a string. Okay. And so in this situation, let's just take a look at what you have here. So really, I mean, aside from the fact that you put the G before the N, which is a spelling mistake, not a big deal, right? It's because it'll still work. You did the same doubles, and then you just added basically one additional double, which was this goal time thing here at the end. And we also changed the return type from double to string, right? So those are kind of the main changes there. All right. Inside the function, we set up a variable here that does basically what we did up top, right? We ran, the function that we already created, right? So this is kind of interesting because what we're doing here is we're calling one function that's calling a different function, right? Which we already know how that operates, and we know it works, right? Because we just tested it, right? And then once that is complete and the pace is stored, then we check to see if that pace is less than the goal time, right? In which case they're doing fine, right? So keep it up. And if they're not, then you're sending them a message saying, yeah, you got to hurry up a little bit. You got to push it a little harder. All right. So when we want to really get all the results now we're calling this one function, which then subsequently, so we're going to call whatever you want to call that name, which calls this function, which then takes us up here, right, to execute stuff. But this call here, it's one concise call that ultimately calls two functions, but they're kind of hidden. So in other words, the advantage of this, here's what the advantage is, that if I decide later that whatever this calculation is up here is incorrect, or I need to add something to the calculation, that type of thing, I can just change this line of code that I've underlined here rather than restructure the whole function. It might only still be one line of code that you're changing, but maybe it's more, right? So this is the advantage. And in this case, the messaging that goes to the screen is really handled by this one, right? That's the one that's handling it. And so, I mean, really combining the two and accomplishing the goal that was set forth. But it is possible that one function can call another, and it's actually very, very common to do that. All right, so I call this our solution, folks. So like if you coded this and you got the same results, you did great. The only thing I would add to this, Jomar, is I would put a print statement at the end so that we can see what the result is down here in the console. Yeah, and what would you print? Motivation. There you go. And yep, keep it up. Now we already did see the results over here in the playground sidebar, but still, it's kind of nice to think about the fact that if it was a running program, that we might want to see that message. All right, so that's gonna complete the functions playground, and I'm gonna take the screen back now. So I'm gonna pause the recording and then restart it once I take the screen. All right, folks, we're now going to move on. We're going to move on to the next of the playgrounds. And the one that we're going to be working on is the structures playground. When you look at the book, and you can notice here, I am working in the teacher edition here. It tells us what all the topics are, which there's not a lot, right? So like this is a teacher's guide, by the way. So what they're really telling you is most of the info that you need to do this is really inside the playground itself. But I like to look at this list because this does show, you know, kind of what it is we're learning and some of the key terminologies. Like if you're looking at any of the terminology that's on that vocabulary list and you're like, I don't know what that is, right? That's an indicator that maybe you want to take a look, right? And then we'll try to hit all of these as we talk, but we may or may not. The other thing to keep in mind is they do have the keynote here. So if you wanted to look at like what a structure is and review it, and you guys know I'm not a huge fan of like kind of doing the PowerPoints for a class like this, but I am very quickly just going to take a look at this code that we're putting on the screen. A structure is a very important part of working in Swift because it's used for a number of different things. And I'm trying to choose my words carefully here because I don't want to say well, structures are really used for structures, that kind of thing. And I think of them, if you're doing a comparison to regular object-oriented programming, sort of kind of like a class structure, but not really, right? It's a little bit different than a class. But it does contain a named block of code, and it contains stuff inside that's either a variable, a constant, or computed. And so if you kind of look at how this is operating here, right? So they take a look at the structure called person, and we have a variable inside of type string. We're not assigning any values. We're just establishing what the pattern is, right? So it's like a template, for how the data will go in. Then down below, we do a let statement, and we say person equals person with the name of Jasmine. And then when I print person.name, and I want you to look at that syntax because this is kind of the important takeaway here. We call this constant we created, which is really based on the person structure, and it has and I think the right way to say this is a property, right? When you have these like variables or constants inside, then I could then access with dot notation, and it's a property because there's no parentheses after it. If there were parentheses after it, it would be a function or a method, but it's a property because it's just a dot, right? So that's kind of the thing. You can ramp these up, by the way, and you can add functions to them. So not only do they hold data, but they hold capabilities to do things. And that could be math. In this case, this can output stuff to the screen. So once again, if I assign Jasmine to the person structure and store it here, this thing that I've stored holds the name Jasmine in this variable, but it also holds the capability of running this function with the data attached to the structure. So when I say person.say hello, notice the parentheses indicating a function, right? Then it can reach the internal function here, execute the code, find its local variable, right? Because declared here, which is Jasmine, and then output it to the screen. So I think that's really kind of useful to see it in that regard. I don't think there's too much more I really want to necessarily add to this, aside from the fact that you can have multiple variables or constants, right? They don't have to be variables per se. And then when you're declaring the structure, and storing values or giving values to it, you feed them in the order and the name that's required. Some of that happens sort of automatically. To just kind of take it, and I'm not going to go like past this slide here, by the way, if you're wondering. But if you look at this structure here, which is a little bit more like the way we're going to be coding here in just a second, we do have a bunch of data that's attributed to this car structure. And so we have a make, year, and color. And then, you know, a car is really good paradigm for this because, you know, cars have things that are just properties. Okay, like what year is it? You know, what kind of car is it? You know, whatever. That's like hard coded information, right? But then cars also have capabilities, and those capabilities, you know, basically are functions within that structure. So, for example, you can start the engine, or drive the car, or park the car, or steer in a particular direction. And we don't know what that code is, but the car's got those capabilities. And by the way, whenever you see the dot, 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 you know, encoding books or classes or whatever, that just means, and there's a bunch of code that goes here. We're not really worried about that, but dot, dot, dot. It's kind of like yada, yada, yada in conversation, you know? So, and then they're showing here that you can create a couple of cars, first car and second car. They're each unique. One's a Honda, one's a Ford, right? It's really easy to latch onto the concept. And then with the first car, right, they're telling it to start the engine and then drive, right? And then, I mean, you can, so these are really nice, solid examples, I think. So these keynotes here, I think, are pretty helpful in terms of kind of like looking at material. And you guys know, I'm not a huge fan of using them, but there was an example of me actually doing so. All right. I am gonna come over here to my Finder now and make sure that I have the structures playground open. I think I already opened it. There it is. All right. And let's start going through the material here and practice it and see what we come up with. I'm going to turn my console on. We'll, you know, we won't need a simulator or anything here, so I might adjust these side panel sizes a little bit. And let's start putting this together now based on their instructions. All right, so it says, imagine you're creating an app that will monitor location. Create a GPS struct with two variable properties, latitude and longitude, both with the default values of 0. So in the examples we looked at in that keynote, when we were throwing variables in, they did not have values pre-assigned. But what this is telling you right off the bat is they could, right? So in some cases you want to assign values, and in some you don't. We're going to use the keyword struct, and let's call it GPS. I'm doing all caps. Okay. We're going to have two variables, right? Why variables and not constants? Well, if this is going to monitor a location, it assumes you will be moving around, right? So they have to be variables. So let's do latitude, preset to 0.0, making it, of course, a double, right? So as soon as I put in that floating point, do another one for longitude. This one also will be set to 0.0. That just gives us a clean starting point. You know, kind of a side, you know, interesting geek note is 0 latitude, 0 longitude a place on planet Earth? It is. There is a spot with that latitude and longitude. And do you guys know where the 0 is for longitude? It goes through Greenwich, England, right? Because they came up with the whole concept of like time zones and and all that. So the 0 point is in England. And then the equator is the 0 point from north to south. So go to Greenwich, England, go straight south to the equator, which probably puts you in Africa or maybe the Atlantic Ocean somewhere. And that's your 0 point. So it is an actual place on Earth, right, if you're wondering. All right. Next, it says create a variable instance of GPS called someplace, right? It should be initialized without supplying any arguments. Print out the latitude and longitude, which should be 0 for both. So let's try that. So I'm just going to say var someplace, And we're just gonna call GPS with parentheses, and this is kind of interesting. And because why are we putting parentheses after it? Well, this is how we do it, basically, is what we're kind of point out here. So if I want to create an instance of GPS without sending any values, I just do this. I call it by name and parentheses. Now, the only reason this is even going to work is because the two properties that it has built into it already have values. If they didn't, we couldn't do this. We would have to send it a value to create it. All right. So then we really just want to do a little bit of output here. So what the author did was this. So I'm just pasting this in, by the way. They're just doing a couple of prints, calling the struct that we just created, and calling upon latitude. Oh, and you see, I copy pasted from the author, and the author has a typo. I think it's funny, right? Considering we had our own typos before. So now, here's like people publishing a book and they got typos in it. Okay, so all right, so like we can report this to Apple and maybe they'll give us free products. Who knows? Yeah, not likely.
No.
Hey, by the way, you made a mistake. Yeah, no free products for you.
Little debugging pop quiz there.
Right. All right, so that's how we do it, and you can see it did indeed output those values. What I do, and I feel kind of compelled to show this, right? So if I like comment these two things out, and I also remove the hard-coded values here, will I get an error message here? Well, first of all, here it's telling me I'm not declaring the type. Okay, it's type double. It's right. I'm not declaring a data type. So let's get that in there. Now would this work? Okay, so now you see the problem. Now, because these do not have a value pre-assigned, I have to declare them here. So like if I was calling GPS here, right, I would need to do this and feed it those values in order to have it work. Right? It's not what the point of that is not to make the change. The point of it is to show you that by having these preset to values, right? And we were really careful about the values we chose because we didn't just type 0.0 implies a double, right? And remember, option click over the variable to tell you, right? Because these are both preset, I can do it this way. If they're not, I have to send the information in. It's just required. You can't have a structure that doesn't have any information. So I think that's an important takeaway. All right. Now it says change some places latitude to 51.514, yada, 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 and the longitude. And now the temptation, of course, is that you come up here and just change the structure. No, we don't want that to happen. We want to change those values after, right? So I can call someplace the thing that, it's a structure here, right? And now I'm going to use the dot notation and I'm going to take the latitude, which is a property, and just set it to something else, 51.514004. And I don't know if that's like a real place because, I mean, they're giving us very specific numbers, right? And then very similarly, we can also just say someplace dot longitude and do the same thing and just use the values that they provided. So 0.125226. And I think that if you took that latitude and longitude and put it on a map, it would be interesting where it would end up. But just based on the longitude, right? Knowing that Greenwich, England is 0, where is this?
Probably someplace really close from there.
Yeah, it is really, really close to Greenwich, England. And yeah, because think of the latitude too, like here where we are in Milwaukee or Wisconsin or wherever. And Jonathan, you live up the road from us. Um, if you travel north on Highway 45 somewhere, there, because I passed it many times, like going to places up north. There's a sign that says halfway to the North Pole, like 45 degrees, latitude. Um, and so 51 degrees latitude is north of where we are, and England is pretty far north, much farther north than we are. They just have the Gulf Stream that keeps them warm until the glaciers melt and redirect the water, and then they'll be frozen like popsicles. Right now, we're just going to print these out. So let's print out latitude, and let's print out longitude. And you see how beautifully simple the notation works, and how once you have the structure built, how it helps you to write your code. So this is another reason why structures are so helpful. It allows us to use dot notation rather than storing everything willy-nilly in separate variables. The latitude and the longitude here in the structure travel together for some specific place. That's kind of the point. So hopefully your stuff is working so far.
So I was curious and I typed in the coordinates. It's just in the River Times.
Oh, really? Okay.
Yeah.
So
Just
you're square in the middle of the river.
kind of, yeah, near the bank. But yeah, it's right there. Just
Maybe
random.
it's the author's favorite fishing hole.
It
Yeah,
could
there we
be.
go.
Yeah, for all we know, we'll turn it into a positive. Or maybe that's where the body's buried.
I mean, Jack the Ripper did have a lot of buddies.
All right, let's move on to the next example here. It says, now imagine you're making a social app for sharing your favorite books. Create a book structure with 4 variable properties: title, author, pages, and price. The default values for title and author should be an empty string. Pages should default to 0, and price should default to 0. All right, so let's try all of those. So let's just do a struct book and do them one by one. So title equals empty quotes. Author, also empty quotes. So both of those are automatically strings, right? You can verify, right? Option click, see, string. Right. And we'll do a variable for pages. And a variable price. Price, of course, will have a decimal point, so it can be a double. So number of pages is a count. Integer makes sense. Price might have pennies or pence or shillings or whatever, since we're in like British mode here. So that would be appropriate. So there's our structure. And, the thing that I think helps structures kind of resonate in your brain, very similar to class files, if you will, inside of Java, for example, but not quite exactly the same. Real similar, but not quite exactly the same. What helps to really understand why you would use a structure is when you think of an object like a book that has complex features, right? So every book's got a title, every book's got an author, it's got a certain number of pages and a price we sell it for. And if you stop and think about it, there's a bunch of other properties books have too. For example, like who's the publisher, who's the editor, what year was it published, hardcover, soft cover, what's the cover look like, so all of those are like really properties of the book. And if we wanted to make a really complex book structure, we could do that with all those properties. And and really, I like to think of structs as kind of a good abstraction. Let's go back to that word, a good abstraction of a real world thing, right? And its properties. When we looked at the car thing in the keynote, that was a good example. And then when you start thinking about it, man, you can think of all sorts of properties for objects, right? And complex programs often have really complicated structures. All right. Now we have a task. It says create a variable instance of book called favorite book without supplying any arguments. Let's just do that first. So let's do a var and we'll call it favorite book. And that's going to be equal to a book. Nothing's being sent in. It has defaults for all the internal properties. So that works, right? We just talked about why, right? And it says print out the title. So let's do that. We're going to print. And then if you remember the syntax here, we're going to take the favorite book dot title. We use dot notation to pull one of the properties back and just put it on the screen. And we know it's a property once again, because there's no parentheses after the word title. And you see, it comes back blank. You know, and if you look at the right sidebar, there's just a slash n. So there's, yeah, right. That's exactly correct because we didn't put a title in. All right. Now they want us to go through and assign values to all of them. And you can, you know, and it says, you know, whatever your favorite book is. And, you know, I know how us computer people are. Most of us don't like to read books. We read screens, right? There was a time where I read lots and lots and lots of books. That was before the internet. So, you know, come up with, I'm trying to think of like what would be a good book. Well, you know what, when I saw the other day when I was shopping, and it was a book. It started as a book first. Is that how you spell Odyssey? That's really weird. It's a weird word. And I think really actually formally it's like that. Great movie, by the way, and a great book. If you guys have not seen that one, you owe it to yourselves to do so. If not only for the reason that it was kind of like the beginning of the modern science fiction era of movies. They were so far ahead of their time in terms of like the graphics and the special effects relative to what was actually capable in reality. All right, then we need to set the author. Who is the author of 2001: A Space Odyssey? I don't know because I've read many of his books. Arthur C. Clarke is the man. We also need a page count. So you favorite book dot pages, and I'm gonna actually set mine. I don't know, just 1,000, something like that. It's probably only 500, but you know, whatever, doesn't matter. And then we also need a price, and I'm not sure. I'm sure you can buy this brand new still. What they would sell it for, so I'm just going to do $24.99. So the point here is we set up the structure, preset values, we create one with the preset values. We proved the presets are there because it's blank, right? Then we go through and we set each one of the properties individually, just using standard like variable, you know, syntax. And then we just need an output statement to show that it worked, right? And so, yeah, I'm gonna copy paste this one in. So hopefully the author's typos aren't too far off, right? So here's the output statement. Yes, it does have string interpolation in it. And so you can take a look at you know how that goes, but you can look at the output down here in the console. So my favorite book is, you know, 2001: A Space Odyssey by Arthur C. Clarke. It is 1,000 pages long. It costs $24.99. That's a little quirky, but to get the paperback copy, I think you can probably get the paperback for about $5.99, right? Or if you're smart, just go to a used bookstore. But that would be an example of it working. So the fact that we created the struct, first empty, assigned values, and then we're able to pull them back. All right. Let's move on to the next thing. I assume you guys got it to work okay?
Yeah.
Oh, so right, man, out. I just grab a screenshot and
I'm going too fast is what you're saying?
not necessarily.
Yeah.
Got it.
Yeah, the screenshots are a good way. And remember this will be out
Oh, I
in
know.
the YouTube universe soon enough as well. If need be. The important thing really here is getting the concept. I am having like a weird effect here. I must have like deleted the link to the next page. I'm gonna control Z. Yeah, I sure did. Okay, that was pretty bad.
Okay,
That's
that's interesting.
crazy that you can even do that.
I agree.
That's kind of an interesting thing. And since we're on the topic here, we're using playgrounds and we're kind of glossing over what kind of tool they are. A playground is really similar. Like if you guys have coded in Python and you've used the Jupyter notebook, even superficially, it's a product that's really similar to that, and it allows you to do coding. So there's like areas of let's call it a document, right, that you can put in your code and it executes. It runs like a regular IDE, and it has a sidebar and the console and all that. The code actually runs, right? And we are inside of Xcode, right? But it also has these non-executing parts, which are really like markup, almost kind of like HTML in a sense. And I'm not sure how to get in there. Maybe that's not the right way to do it. There is a way here. Right here, show raw markup. Of course, I had to look for a while, but this is actually the code in the background that creates it. And so you notice what they do is they just set up comments, right? And if it's on the comment, notice that that's what pops up as text in the document. It looks like if you do this in front of it, it's a title. And it looks like if you do, well, that's just a regular comment. So I don't see that that's just text, right? But that's how they get the words on there. So if I wanted to change, like if you wanted to create your own playground, right, with instructions, you would go into this mode, type up your instructions. And so like if I was a really ambitious teacher, which in a lot of cases I'm not, right? Why reinvent the wheel? I mean, this stuff's so nicely put together. I could manually assemble all of this material in here. It wouldn't be very hard, right? And I mean, I'm figuring out what the nomenclature is very, very quickly. So if I want to do a title, there it is. There's also links, and it looks like links are placed inside of square brackets that then the link for it is next, which must mean next page, right? So there's like the lifting the veil, off the mysterious thing that are playgrounds. But very cool thing, right? Yeah, and yes, I can break it, so I can highlight this and break it just like anything else. But I can also edit it and change it to be something completely different, right? So I could see like in the future, if I did a lot of teaching in here, I might take these playgrounds and adjust them, and make them my own. You totally do that. Or if I didn't want my students to have the answers, right, I could come up with exercises that are different. So if they watch my videos online and try to get the answers, they wouldn't get them, right? I'm not that kind of sneaky though. So that sounds like a whole lot of effort that I don't want to put in. Right. Because to me, and I'll be real frank here, I'm not so concerned about this philosophy of like making it as hard as possible, quizzing people, and maybe they'll get it right and be a good student. My real more important driver is that you understand what's going on and that you can get it to work, right? that to me is way more valuable than proving that you can figure something out that somebody's trying to trick you with. So, all right, let's take a look at this next thing. And this is an app exercise. And I think what we'll do is let's work on this exercise and then we'll roll in a break here because we've been going for a bit. All right, so these exercises reinforce Swift concepts in the context of a fitness tracking app, which we're kind of getting used to seeing that every time. And it says your app wouldn't be much of a fitness tracker if it couldn't help users track their workouts. So in order to track a user's run, you'll need to have some kind of a data structure that can hold information about the workout. For the sake of simplicity, you'll focus specifically on running, right? So we're going to create a running workout struct, right? And I do want you to notice here that they are using the convention very much like we do in Java, by the way, that whenever you name a struct, that you do start with a capital letter. So running workout, right? Curly brackets, right? And then we're asked to create variable properties for distance, time, and elevation, right? All three should have default values of 0.0. So all of them are doubles. So here's bar of distance, 0.0, a bar of time, also 0.0, and a bar of elevation, also 0.0. So there we are. Then it says create a variable instance of this new struct called first run without supplying any arguments. So let's do that first. Bar first run equals running workout with parentheses. All right. Now we are presetting the values so this works, and then we're just going to do printouts. We're just going to say print first run dot distance, print first run dot time, and print first run dot elevation. And I'm looking at this one. Are you guys noticing? I don't know if it's my Xcode or whatever, but that one's not color coding. So it has me going, why is it not color coding? And I'm not really sure. It's just not. But it does seem to be working because it is pulling back to 0, and I can see it both in the console and the sidebar there. All right, so now it says, imagine that throughout the course of the run, you go a distance of 2,396 meters at 15.3 meters and get 94 meters of elevation. Update the values of all the properties accordingly. So this is just practice now. This is like repetition, right? So we're going to say first run dot distance equals 2396. First run dot time equals 15.3, and first run dot elevation, we have a gain of 94 meters. I think the other thing that's kind of interesting here, and I don't know if you guys pick up on these little subtleties, but when I was doing this, right, and I'm pulling up one of the properties and I hit that period, you notice in this little IntelliSense box that pops up, you notice the letter P next to each one of these, and it tells us basically that these are properties of the structure. So it's actually reading into the structure, finding the 3 properties, and telling us that they're properties with the P, right? So I think that's a pretty cool little feature here. Now, of course, we're going to want to do an output statement here again to make sure that all the stuff actually changed. So that I'm going to copy paste that in. And this time I won't blow away the markup, right, like I did last time, or at least I hope I don't. And there's your example. So, the point of this, of course, is to show that we did set the properties from the defaults and that they stuck, and we can put them up on the screen. All right. I'm going to go ahead and I'm going to pause the video here, and then we're going to take a break. All right, we are back from break, and we are just going to pick up right here where we left off. And this one's about member-wise and custom initializers. So there's some, let's call it syntax or terminology here that you might be interested in learning. And so let's see what they say here. They say, if you completed the exercise structs, instances, and default values, you created a GPS struct with default values for latitude and longitude. Just did it, right? It says create your GPS struct again, but this time do not provide default values. You guys notice that we kind of already did this, right? So I'm sorry for short circuiting this, but that's okay. Let's just do it. Do what they say. And we are going to create variables for latitude, spelled correctly. It's a double, and longitude also. And just a reminder here, the reason I have to declare the data type here is because I'm not assigning the value, right? Or if I assign the value, I assign the default value in a format that's of the data type that we're declaring. All right, so now we have it set up without default values, and you can figure out very quickly where they're pointing us, because it's basically the same thing that we did before. But here's the difference, right? This one doesn't have the values set. So if we are going to set it, we have to feed it in when we call the struct, or when we, I should say, instantiate or make a copy of the struct. Notice that I'm using a let statement here. So whatever I put in here, ultimately the values aren't going to change, right? But we'll call the struct, we'll use the latitude and longitude because that's what it is. And then we'll put in the Thames River fishing spot, right? That's what we figured out. This is, right, somebody's favorite fishing hole. What the creature from the Black Lagoon is, who knows? Right? And then, so this time we're feeding in the values. Right, so this is another way to set them, and then we can go directly to printing them. And really, we've kind of wrestled with this stuff already, so this is just really repetition and reinforcement is how I'm thinking of it. There you go. You can see that it does pull those values. It also wants us to do the same thing with the book. So, we had a book struct. Now, if you wanted, you could go back, right? So you can come back here and you could copy the book struct. In fact, I'm going to do that just because I'm lazy, basically. So I'm just going to copy that, and we're going to adjust it here. And we're going to remove all the default values and just provide a data type. So title would be a string. Author also be a string. Pages would be int. And price would be a double. So there it is, without any default values. Once again, we're going to do the same thing that we just did above, and that is we're going to declare, and in this case, I think it says declare your favorite book instance. All right, and I don't know why above they declared GPS with a let, and here they're declaring it with a var, but I'm going to declare it with a var just like the author did here. And we're going to call this once again favorite book We're gonna call the struct, we're gonna use this structure that it's pulling right from within it. And then we're just gonna populate it with, oh gosh, now we need another book, right? Here you go, War and Peace. Wait, let's have fun with this. Snoopy come home. How about that? So it's a little more lighthearted, right? And I don't know, come up with a page count and a price. So, but the whole point is here that as we're creating this, right, we are applying values to all the properties. And if you're wondering, what is a member-wise initializer, that is when I type book and it reads all the variables in. It goes title, author, pages, price. It's telling you what the members are. And as we're entering in the data in these spots here, we are initializing those values. So member-wise initializer simply means that the IntelliSense is finding the object, what members it has, their data type, and allowing me to propagate those values immediately as I create the object. So that's what, when somebody throws around that fancy word, member-wise initializer, that's what it is, right? It's the fancy word for something that, we've kind of been doing all along. Right. So and I'll tell you what, I think that's a great way to learn terminology, is just to know how to do something. And then you're like, oh, that's what it's called. Right. Because rather than like, hey, there's this thing called this, and then you have to learn how to use it. That confuses your brain, I think, a whole lot more than just, working with it. Now, of course, we're going to need to output this. Right, so I'm going to come and grab a print statement here, like I have the last couple times. This is just already prefabbed from the author. So just, the point of this mostly is just to see, did we really set the values correctly, and are they coming back the way that we expect? And it looks like it's working just fine. Hopefully you guys are all right with this one. All right. This particular one is a little bit longer, right? And I hope I didn't skip over something. All right, well, the teacher version has some extra stuff in it. All right, so I think, yeah, I did delete something again. All right. It must be the way I pasted it in. I must have grabbed too much stuff and it overwrote this laptop thing. All right, let's do the laptop one. It says make a laptop struct with 3 variable properties: screen size of type int, repair count of type int, and year purchased of type int. All of them are ints. Give screen size a default value of 13, repair count a default value of 0, and year purchased will be left without a default value. All right, so let's see if we can interpret that correctly. So we have a struct, we're going to call it laptop, and close curly brackets. We'll start with screen size. That's going to be of type int, because they told us to make it an int. And the default size is 13 inch. Then we'll do a repair count, like so, also an integer. And this one will be preset to 0. So hopefully you buy a brand new laptop and hopefully it hasn't been repaired already, right? And then the year purchased. Sure. This one, okay, so this one they said don't set a value. So that one we're going to leave alone. Now, you can already tell, like, one of the things that's happening here is that now we're mixing the 2 approaches, and you can do that. Okay, so then the question becomes, well, how do you do that, right? Well, first, let's declare a variable and call it personal laptop. We're going to call the laptop struct, right? And you can see here, like really carefully below on this IntelliSense list, that I can pull in all three of the properties, right? And then apply values to them. That is not what I want to do here, though. I don't want to set it for the defaults. The only one I have to set is year purchased, right? And so for me, it's been, gosh, 3 years now since, well, not on the machine that I'm on now, but last time I went to a store and spent money to buy a machine. That's a good way to say it. It was 2021, and that's 3 years already, right? And it's a PC. So usually for PCs, you're almost at end of life already. You're like, I'm thinking about another one, you know? Fortunately, I bought a gaming laptop, so it's not quite so obsolete. Right, but that one has to be there. Notice that the others don't, right? But that one has to be there because year purchase is not predefined. Now, let's create another variable and let's call this a refurbed, refurbished. And with this one, we're going to populate all of the fields up front. So the screen size is 15. And you see what happened to me there is I lost the IntelliSense. So what am I doing? Rather than type it out manually, I'm going like this. And I want it, you know, you notice I want it to pull up all three fields and it's not doing it. Right? That's because screen size and repair count are already set. So if I want those in here, I do have to type them manually. I'll just put in a year since I'm here, but I'm going to go back here and then manually add screen size. And actually here, let's do it like this. I'm not going to keep the year purchased, but I do want to show you that the IntelliSense will still pull the stuff up, right? So let's see if I type screen size, now it puts it in, right? But it's not putting in repair count. But can I put it in? Yeah, I can put it in. So it still reads the IntelliSense, but it, you know, so some of this like kind of goes to what is practical when you're building these things. It really kind of depends on your scenario. Our screen size, we're going to put in 15. It's a refurb, so it's been fixed at least once. And the year purchased was, let's say 2020. All right. And notice here, we're not even worried about putting this stuff back up on the screen. You could do output statements if you want. So let's try this next little exercise. This is more about how it's created and what happens if you're mixing, you know, the two approaches. That's really what that was about. This next one says, make a height struct with two variable properties, height in inches and height in centimeters. Both should be of type double. Create two custom initializers, right? All right, now this is something that, you know, we talked about in the first course really briefly, and then kind of walked away from it. These are kind of like the constructor functions in Java. So, you know, for some that might resonate, for others it might be, I don't know what that is, and that's fine. But what the initializers are is ways for us to be able to create the struct using different approaches and different information, right? So in other words, this will kind of morph and allow us to build the structure using two different approaches, provided we're wise and build it wisely to begin with. So let's do the building first, and then we'll talk about what stuff they're asking for. So I'm going to start with height, right? That's what we're supposed to call it. And we're going to set up a variable called height inches, which is going to be a double, and another one called height in centimeters, so a double. All right. Now that get into these kind of specific instructions, and you notice I'm creating a little space here in my struct because I do expect to type a little bit more. And it says each initializer should take the passed in value and use it to set the property that corresponds to the unit of measure passed in. So in other words, if they send in centimeters, then we're gonna set the height in centimeters, right? Or if they send in inches, we're gonna set the height in inches. And then switching it to the other format is a matter of mathematics, right? So we can pass in one value and then the math can set the other value. So we'll pick either inches or centimeters, and then the struct will automatically adjust. Kind of clever, right? Now, if we use an initializer, there's a keyword that we use called init. I don't know if you guys recall this or not from the first course. It was very brief, right? So we do init with parentheses and curly brackets. Now, inside here, we want one to respond to inches, the other one to respond to centimeters. So I'm going to call this one height. And inches. That's what we named it above. And that's going to be a double. So it's going to receive inches as a double. Inside the initializer, we're going to use the self-referencing keyword. So that's pointing back to itself. Which structure are we talking about? Myself. You know, basically that's kind of how the reference is. And we're going to set the height in inches to be the height in inches that was passed in. So in other words, this value will get passed in, it'll end up here, and then it gets stored here inside the structure itself. Right, that's how that reads. Now, as we're doing that, and I mentioned before, what the height is in centimeters is just a matter of math. So if I say self dot height in centimeters, that will be equal to the result of height in inches multiplied by 2.54. That's the conversion rate for centimeters. So 1 inch is equal to 2.54 centimeters. But it's setting both of the properties automatically. I'm sending in inches. Well, inches is inches, centimeters gets converted. We'll do the same thing, but in the other direction. So we'll do another init. Here we'll do height in centimeters. So a double. Those curly brackets. And then once again, we'll follow the same exact pattern. So we'll say self dot height in centimeters equals the height in centimeters that we're sending in. And then the object's height in inches will be calculated by taking the height in centimeters and dividing by 2.54. So those are, go in one direction and the other. So if I have, 25.4 centimeters, I will have 10 inches. Right? Right. But once again, sending both at the same time. Okay, so now it says, and let me make sure that all of that's on screen at the same time here. Now it says create a variable instance of height called someone's height. Use the initializer for inches to set the height to 65 and print out the property for height in centimeters to verify it's equal to 165.1. So they're giving us the solved values here. So what we're looking for is something like this. We're just going to say var someone's height equals the height struct. See, I want to let the IntelliSense help me here, right? And which one am I feeding in? Inches, right? That's what we're told to do. We're supposed to feed in 65 inches. And then we need to print that out. So let's do a print. We're just going to print out someone's height in centimeters, and that's 165.1. So our math is working. Now it says create a variable instance of height called my height and put your own height in there. And then verify that both your height in centimeters and inches are correct. And you guys can just follow what I'm doing, because I would anticipate that you don't know your height in centimeters without doing like math or pulling out your metric tape measure or whatever. So you can just follow with what I'm doing here. And if it jives, then we're okay. So in this case, we're going to start with centimeters. So we're feeding in this one. We're going to send in 165.1. Why? Because that's the number we got before. So we know what the correct answer should be when we do the output, basically. So what are we going to print? My height and the height in inches. And you should see in the sidebar here 65. So we started with 65 and we're going back to it. All right, so I'm hoping that worked out for you guys. Everything worked okay?
Yep, it's working for me.
Excellent. I'm going to move on to the next one. If you guys do need me to backtrack, just say so. Not a big deal to do it. All right. We're going to go back to the whole fitness tracking app again, right? And you can see it's pretty pervasive that we just keep working on it. And it says for most apps, you need to have a data structure to hold information about a user. Create a user struct that has properties for basic information. It should have at least a name, age, height, weight, and activity level. Name can be a string, age and int, height and weight, doubles, activity level, and int. All right, let's try doing that. That's a lot. They're asking for a lot of stuff there, so let's get busy on it. So let's build a struct. We're going to call it user, those curly brackets, and let's start with the name. So we're going to do var name, type string. We were not told to set any defaults for anything, right? We were not. Then we're going to do an age, int, height, double, weight, double. And then what was the last one? Activity level. Of type. That's going to be on a scale of 1 to 10 for activity level. Right, but there's our struct. We have the pieces in place at least. Next, it says create a variable instance of user and call it your name. Use the member-wise initializer to pass information about yourself, then print out a description. All right, so I mean, you don't have to invent info, but at the same time, you don't have to use your real info either. So I'll leave that up to you. So I'll actually put my real name in there, whatever. I really don't care. And I think this is actually kind of interesting because the author is using a lowercase version of their name here, and then when they add the member-wise initializer, they use uppercase, so whatever. So I'm just doing the same thing. So I'm going to use the user. I'm going to pull in the member-wise initializer. Why? Because it's easier. I mean, it really is just about as simple as that, right? And then I'm just going to pop through these and answer as honestly as I can. Oh, did I type 29? I meant 59. Height, oh gosh. I guess I'm not sure how many inches I am. I gotta do math to figure that out, right? I'm 6 feet tall. How many inches am I? You guys are thinking about it, right? What's 6 times 12?
I'm like thinking of my own really quick.
Yeah, I guess I'm 71 inches high, and I think I'm hovering right around this weight, which is not too bad. My activity level, I'm gonna put it at like a 7. you know, 10 being really active. I'm fairly active for a person my age. All right, so there's my member wise initializers with supposedly real data. Next, you're going to need to do some output, and we are going to do string interpolation on this. And I am pasting, and I'm watching to see if I'm blowing away my markup again. Nope, this time I did it right. But there it is. And I'm just wondering, what did I do? Oh yeah, well, they're using the name Jacob here, and unfortunately I use the name Takis. I gotta fix all those. That's what you get for copy paste. Sometimes copy pasting is not faster. I still think it's faster. Okay. But notice here, like when we do the string interpolation, that we can use the properties right in the string interpolation spot. And we kind of have been doing it, not talking about it, but you can. And it doesn't matter if it's a string or a number. When you're doing string interpolation, everything gets converted to a string. But you can see at the bottom there, you know, that it's outputting correctly with the right information. So we were able to assign the values and then make sure they stuck and then output them. All right, so there's the code for that one. All right, let's move on to the next one. This one says, in previous app exercises, you've worked with distance as an example. So distance in the fitness tracking app is an example as a simple number. However, distance can be represented using a variety of units of measurement. So create a distance struct that will represent distance in various units of measure. At a minimum, it should have a meters and feet property, and create a custom initializer corresponding to each property, and then with the conversions that go with. So this is kind of like what we just did before with inches and centimeters, but now we're going to do it with meters and feet. So this is our see if we can kind of drive it on home from that, right? So we're going to have two initializers after we create the struct. Let's make the basic struct first. So here comes struct distance, the curly brackets. Then we're going to have one variable for meters, which is a double, another for feet, which is a double. And then what they're telling you here is if you wanted to convert this to inches, centimeters, kilometers, miles, you know, I don't know, parsecs, you know, whatever unit of measure you want to use, you could do that here, right? And you could do the math and the conversion. The point is, once again, that we want to allow them either to enter meters or feet and have it automatically convert. So we will create an init, which is an initializer, right? And we'll do the first one with meters, which is of type double. So it's going to receive a double, or curlies, and then we'll use the self-referencing variable, and that's going to be set to the meters that were sent in. And then, of course, we have the feet, and we want to set that property as well. And in this case, we're just going to say meters times 3.28084 is what we're provided as the conversion rate. So there's 3.28 feet per meter is what that tells you. All right, so if we feed in meters, we will get the correct number of feet. We'll do another one of these, and this will accept feet instead. So here comes that one, also a double. And once again, open close curly brackets. And same thing we did before, but we're leading with feet this time. So we're going to say self.feet equals feet, and self.meters equals feet, divide by that same number, 3.28084. 28084. Very, very similar, right? So the conversions are calculated here right when we create the structure. Now it says create an instance of distance called mile. So let mile equal distance, and we're going to supply meters, which will be 1600. Why? Because we were told to, basically. And then we're going to print mile dot feet to show the conversion did happen, right? So 1600 meters equals 5,249. If you guys remember how much a mile is, so 1600 meters is really close to a mile, right? Because a mile is like 5,280 feet. So we're just a few feet off. All right. As you can imagine, we're going to just keep kind of going with that example. And we're going to create another one. And I'm going to call this one 5K, like a 5 kilometer distance, right? I'm going to call distance. I'm going to feed into it this time by sending in meters. Well, how far is 5K? Well, it's 5,000 meters. So I would send in meters and I would do 5,000. And we could print that. And what would we print? 5K feet. So 5,000 meters or 5 kilometers is 16,404.2 feet, right? You could go the other direction on this, and they're not really talking about this. I don't know, you can call it whatever you want, my distance. And in this case, we could send in feet. So we could send in, for example, 300 feet. And then if we print my distance in meters, you can see it's 91.4 meters. So an American football field is not quite 100 meters, right? It's a little shy of that. All right, so that's an example, kind of going both directions. And I think this is a really nice usable example because we are calculating the properties, and I think that is a very useful aspect of structs if needed, right? The fact that you could calculate values and then it becomes kind of part of that structure automatically. You guys good?
Yep.
All right.
Yep.
Let's move on to methods. All right. So methods are things that we've been kind of using for a while now. And, at this point, we're going to start applying them to structures. We sort of kind of have been doing it because like that initialization function really is a method, truly, because it's internal to the structure. But now we're going to have, instead of, calling, what we call the constructor, to build it, we're going to actually have a named function inside of the structure that will call by name and include the parentheses, which is something we don't do with the properties, right? And that's how you know it's a method or, interchangeably a function. So here we have a struct that's already defined. A title, author, pages, price looks familiar, right? With data types declared. And it says, add an instance method called description that will print out facts about the book. So here we would create a func and we will call it description. Notice, because it's a method, we're starting with lowercase letters. That's kind of interesting. That's kind of a convention here. If I'm going to have a function that just prints out facts about the book, do I need to receive something here inside the parentheses? Well, the answer is no, I don't, right? Because if I'm just going to print out this information, that's already in the structure. So it doesn't need to go anywhere to get the information. It's already there. So then really what it is just a clever print statement here. And yes, I'm copy pasting in for speed and accuracy, but you should build character by typing it in manually. All right, using string interpolation again. So we'll list the title written by the author, is X number of pages long and costs so many dollars, right? Now, in order to test this, of course, we have to write a little bit of code. And I'll move slowly on this, I guess. Let's start with a let. And I'm just once again going to call it favorite book. We're going to use the initializer here. So I'm going to call book. And we'll pull in all the pieces of information. And then I'm borrowing from our author here because he used Hamlet. The author is Shakespeare. Pages are 80 and the price is $9.99. Then, so and see why this is kind of useful. Think about all the examples we've been doing so far. You build these structs, we put stuff in them, and then we type up these really big long print statements to prove it worked. Now the print statement's built into the structure itself, so I don't have to do all that. Right. Well, I had to initially. Now, if I want to see what the details are, I can just say favorite book dot description. Notice the parentheses because it's a function, and now it just does it. That's so, isn't that kind of cool, right? So like the capability of the structure providing information about itself is just built right into the structure. And we're just calling it as a method like this. Really simple dot notation. Pretty powerful, but simple. You know, and I think that's kind of a neat thing. So if you have a need for that information over and over again, it makes sense to build it into the structure. Right. And then you just call it as a property whenever you need it. All right. The next little example here says, a post struct has been created for you below, representing a generic social media post, and add a mutating method on post called like that will increment likes by 1. Then create an instance of post and call like on it, and probably more than a couple of times, and then print out the likes property before after calling the method to see whether or not the value was incremented. All right, so let's do this. So we have a post. The post contains a message in the form of a string, a count for the number of likes as an integer, and then a counter for the number of comments, also an integer. All right. It says, the second sentence up above there says add a mutating method. And mutating, okay, so here's kind of an interesting thought here. What does mutating mean as a word?
That means we can change it.
Precisely. That means that the function can be changed, and it's going to, allow for things to happen, basically. So I'm just going to add that here, and there's a keyword that we're supposed to use, which is mutating, and you can see it tried to get me to take the autocorrect, so I backtracked until I got it right. Why? I don't want to misspell it, so we're going to call this like, and then add our curlies. Every time we get a like, we're going to take the like property and we're going to plus equals 1 to it. So we're going to add a like every time they like, right? And that often is, in social media is seen as, kind of a barometer of the success of a post, right? It's actually called likes. That's why I was getting the underline there. So I just fixed it. All right. So there's that method. Let's now go ahead and try to create an instance of this. And so here's what I'm gonna do. I'm gonna call it a var because I expect it to change, right? Because we're gonna keep liking it, right? And then I'm gonna say, I'll call it some post. So we're gonna pull this up. And let's just put in a message. So somewhat timely, I should say. So this would be kind of like the text of the post. And in this case, did anyone watch the Super Bowl, right? And let's preset the current number of likes to 18 and the number of comments to 9. Okay. Now let's go ahead and do a print. So we're going to print my post and the number of likes. I'm just going to pull the property back, and you can see right now it's 18, right? Now, if my post gets a like, singular, right? Because that's what we call the method, like, and then I just simply repeat this method or this message, right? We should see that now increment to 19. And then, if you want to really test this, right? Basically what they're trying to point out is every time you call this method, it could be once, it could be twice, whatever, it is mutating one of the properties. So it's changing one of the properties in the structure. And then when I go and look at that property again after I've had 3 more likes, now this should be 22. Right? I can't change the other values. I mean, I could change the number of comments by just going some post dot number of comments equals more, but I don't have a mutating method that changes it for me. You see the difference? With this, I call the method does what it does. It's changing one of the properties, and then we can see that it's actually working. So that's what we would call mutating method. Mutating, once again, means to change things. All right, we're going to move on here, folks. All right. Here's one of our exercises coming up now. Once again, back to the fitness tracking app as usual. It says a running workout struct has been created for you below. Add a method called post workout stats that prints out the details of the run, and then create an instance of it called post workout stats. And we'll kind of take a look at that point. So why don't we do it like this? I'll start coding, but I want you guys, like, in your own head here, like, to think about how you would accomplish this if you weren't watching me do it. Because I think on one of the future exercises here, I'm going to make you guys kind of do it on your own. So
Okay.
try to get your head into that space. So here we are. They told us exactly what to do. So they want us to add a method. So we're just going to create a func here, and we're going to call it post workout stats, parens and curlies, right? And then we're just supposed to do a message. So I'm gonna type this out the long way this time. So I'm gonna say, what am I gonna say? We have distance, time, and elevation. You know what? I'm gonna do it like this. I'm gonna do distance, little string interpolation, and of course we would pull in distance. Then I'm gonna go Well, distance is what, in meters? All right, yeah, we'll do distance in meters. So I'm gonna put a little M after it. And then I want to move down to the next line. So I'm gonna do \n. And then I'm gonna display the time, colon space, and then of course the time. And the time would probably be in seconds. I think that's what we're supposed to provide. And then we'll do another new line, so \n. Then we'll display the elevation, space after it, and then, of course, string interpolate the elevation. So, and we'll do elevation in meters also. All right. So you notice what I'm doing here is I'm gonna have 3 lines of output, but with 1 print statement. That's kind of the point here. But this is built in. So in order to test this, we have to go like this. We're gonna create one of these. We're gonna let our run from the day, create a new thing here, and we're going to use the distance, time, and elevation. And we'll hard code these values because they're given to me. So we know what, the distance is 1,600 meters, about a mile. Time, 358 seconds. And the elevation is 12 meters. All right. Now that we've got this information entered in here, now what's left to do is to prove that it worked. And this time we're just going to reach in there. We're going to call post workout stats. I want you to notice once again in the little panel, the little M, which is the signature for a method or a function that's part of something else. And then that will reach into the structure, run that print statement, and then you should see in the console here, once I get off this line, hopefully the right result. Right now, I'm not sure if my xcode's locked up. Did I misspell anything? I don't think so.
Oh yeah, I think yours is locked up because mine's displaying.
Yeah, I think you're right. But you notice what I did here is I made a change and I waited for this to like run. Hopefully it would run. So I think I'm gonna have to. All right, we're gonna quit xcode and relaunch. Not exactly what I want to do, but you know what? Not a bad thing to record into the video because this is kind of what happens to us when we're working. So, all right, so here comes the structures coming back, and let's see if it loads up this time. And there we go. And then notice the output here on the bottom. All right, so hopefully that worked for everybody. Let's go to the next part. All right. Next, it says a step struct has been created for you below, representing the day's step tracking data. It has the goal number of steps for the day and the number of steps taken so far. Create a method on steps called take step that increments the values of steps by 1, then create an instance of steps and call take step. All right, so in other words, this sounds really familiar with what we did before, right? So mutating function once again to do this. And every time, and so instead of likes, we're counting steps. That's kind of the difference. And so we'll follow that same pattern. The first thing we do have to do though is we need to add a mutating method here. So we're going to call it mutating. And it's going to be a func, and it's supposed to be take step. Kind of like an action, right? Relative to the structure. And all that's going to do is it's going to take the steps and we're going to plus equals 1 so step. Yeah, that's how it's going to work. All right. Now we need to create one of these. So we're going to make it as a variable because we're going to be changing the number of steps. We're going to call the structure And we'll use the member-wise initializer. And we'll do 598 steps with our goal being 10,000. Tab again. All right. Now, let's do a print right away and see if it stuck. So we're going to say steps dot steps. It's kind of confusing, but descriptive, I guess, 598. So it did stick. And then we're going to do a steps dot take step, which should add one. And then we can just repeat that print statement to make sure. And does it go up to 599? And then, of course, if you want, if you really want to test how it's working, you just simply can take a bunch of steps, and you can see they're all on the same line, and that's not where I want them to be. There you go. So we took 4 more steps, and then let's check it again. All right, it should be up to 603. Sounds good. So our math is working, but goes in there, it changes one of the properties, and it's allowed to, and we can still extract the information. So taking a mutating method here that triggers an action, right, recalculates one of the properties, and then we show that it's actually changed. All right, so hopefully you guys are good with that. I'm sure if you're not,
Yep.
you'd let me know, right? All right, let's move on to the next one. All right, so now we're going to work a little bit with computed properties, something that we've talked about and sort of played with, but not exactly in the traditional kind of a way. This is, I like this example because we start with a rectangle struct here. And what we're going to do is, if you have a rectangle and you know the width and the height, that's enough information to calculate a whole bunch of other things about that rectangle. So one really good example would be that we can create a computed property. So I want you to notice how this works. This is kind of like setting another property like this, right? So we still give it a name, excuse me, and a data type. But we add curly brackets to it, and there's code that's inside here. And what we're going to do is we're going to take the width and multiply it by the height, because that's how you get the area. What is it computing it from? Stuff it already has. And that way we can just ask rectangle dot area, and it does the calculation for us, provided width and height are provided. All right, let's test it. So we're going to set up a var here. We'll just call it rect whatever. We will build the struct. We'll put in how about a width of 4 and a height of 5. You know, 5 times 4 is 20, right? So, that's why I use simple numbers to start with. And then we're just simply going to print the rectangle's area. And then hopefully in the sidebar, you see 20. You see how that's operating, right? So in terms of the code, it looks like a property. There's no parentheses after it, but there is some calculation going on. We don't have to send it anything, right? We're not returning anything. It just calculates it and stores it here based on the values of the other things that are already present. All right, now we're going to do a little tweaking. All right, so here it says, in the height struct below, height is represented in both inches and centimeters. Remember this just a little while ago. However, if height in inches is changed, height in centimeters should also adjust to match it, right? A did set to each property that will, so it says add a did set property to each property. Okay, so I'm like reading that really not well, right? Add a did set to each property that will check if the other property is what it should be And if not, sets the proper value. So it's basically what we're going to do here is we're going to check to see if we change one of these, did the other one change automatically? Because think about this, when we create the object, we're automatically, if we send in inches, it automatically sets centimeters. If we send in centimeters, it already automatically sets inches. But what happens if after the fact we change the inches or the centimeters? We want to make sure that the value gets updated to match, right? Because then if you ask for centimeters, it could be wrong, right? So this is kind of a little bit of a logic thing. So we're just dealing with the original version that we had before. However, inside, you know, the way that we have these, and I want you to like just kind of think about this here for a second. Right now, these are just kind of standalones. This is how we've been doing structs. And then we had the initializers that would do the calculations and set the other one for us. But what they're really asking for here, and this just, it takes a little bit of reading to kind of really kind of catch it, is to take the original property, right? Add a set of curly brackets, not squares, but curlies after it, and then come up with another named function here inside here. So watch how I do this. I'm just going to use the word did set. This is kind of a convention, by the way, with another set of curly brackets that will do the conversion for us. So for example, let inches and centimeters equal our height in inches multiplied by 2.54. The same calculation we did before, but this is hard coded. That conversion would be hard coded. All right. Then we'll just do a check, and this is an if statement. We're going to say if the height in centimeters does not equal that new calculated value, we have another set of curly brackets, then we're going to adjust the height in centimeters to that new value. Isn't that clever, right? And you might not see it as clever right now, but you know, this allows us to basically set it originally. The conversion happens right when we set it, just like it did before. But now if we change it after the fact, it will also update. So a very, very brilliant kind of approach. We're going to do the same thing here to the other one. So we're going to add curly brackets, right? We're going to add a did set method inside there with curlies. We're going to let in inches, right? So you see like kind of the parallels here, equal the height in centimeters. That's the thing we're converting, divided by 2.54. And then the same if statement with altered language, basically. So height in centimeters, if that does not equal what we just calculated in inches, then the height in inches will equal the one that we just calculated. Right. There's no else here, right? That's only going to happen if it changes and they're not equal. The other stuff that we have in here, the initializers, here's the question: do we need to get rid of those? No, not at all. We don't have to get rid of them at all. We can leave them in place. No harm done, right? So that's the completed struct then with all the computed properties.
Yeah.
Now, what's left to do is to test it, but I'm going to just leave it here for just a second as you guys type it in, and just make sure your syntax is right, because it's easy to kind of confuse the different variable names and, you know, all that. Just, you know, so take a moment and just make sure everything's lining up.
Yeah, no, it should be all good.
I actually have a question.
Sure.
On that first did set, we have the in centimeters equals height to inches times 2.54. And then the if statement is height in centimeters is not equal to in centimeters. Then height in centimeters equals in centimeters. How come the if statement in that second one doesn't match fully like how that first one does? Because I see that if the height in centimeters is not equal in inches, then height in inches equals in
Oh,
inches.
yeah. What you're doing is you're catching one of my mistakes. You're right. So this right here should be inches.
Okay, all right.
Yeah.
Now this is
No, that's a good catch. That's just hasty typing on my part.
I just wanted to make sure I was understanding correctly.
Yep. And that's my first mistake of the year. So
Long year.
Let it be noted.
first mistake this year in this minute, right. But yeah, that was a good catch because that is the correct fix there. And now you're making me check all my other code to make sure that's right too. Right, which you should do. All right, but that is the completed struct there. Let's go ahead and try this now. So I'm going to come down here and I'm going to create a var. I'm going to call it height. And then we're going to call in the height struct. And we're going to feed to it height in inches. Let's feed height in inches. We'll set that to 71 because that's where I'm at, right? And then and here's where it gets a little weird, right? So let me show you what the author is doing in their solution. The author is doing this. So they're changing that height and they're taking the property height in inches, which we just set, right? And we're moving it from 71 to 75. When I do a print, I'm going to print out the height, but the height in centimeters, which comes up to 190.5. Now the question becomes, is that correct? Right, so here's one way you can figure it out. So I'm going to bring up my calculator. Right, if I take 71, which is inches, and multiply it by 2.54, the centimeters is 180.34. Right, so that seems to be right. But then if we go to 75, like that, there it is, 190.5. So it's showing you, even though I created it with this height, I then was able to change the height, which then automatically changed the centimeters too. So when I reached in here to change height in inches, I did the calculation for comparison, check to see if they were the same. If they're not the same, it set it for me. And that's kind of the takeaway here. Now, one way that you could test this, and the author doesn't do this, which I think is a little disappointing, honestly, is maybe put that statement here so you can see the difference, right? So you can see it 71 was actually 180.34. When I moved it to 75, it did actually change to 190.5, and it's showing me that did actually set the value correctly, but only if it didn't match. So these are, I think, intelligent, calculated properties here that, and of course it's situational, right? So we're just using examples right now, but if you had a real world situation that's applied to, the situation would dictate what your calculations and property or calculated properties should be. All right, moving on to the next one, folks. All right. All right, this one says these exercises reinforce Swift concepts in the context of a fitness tracking app. Right, so we're saying that so many times it's becoming a routine again. Once again, we have a struct here, running workout, holds info about your users running workouts. However, you decide to add information about average mile time. Add a computed property called average mile time that uses distance and time to compute the user's average mile time. Assume that distance is measured in meters and 1,600 meters is a mile. So they're kind of, giving us some givens here for a reason. And so they want us to basically figure it out relative to basically a mile. All right, so we have the 3 given properties there, but now we need to add one that's calculated. So I'm going to just come in here, add a blank line, and create this, which I'm going to call average mile time as asked, right? This is going to be a double, and this is computed, so we're adding curly brackets to do the computation. And all right, so how would we determine what are we trying to figure? Average mile time? Well, we would take time divided by distance and then multiply by 1,600, which is basically a mile. Assuming once again that distance is going to be entered in meters, and then this is going to convert from meters to mile time. So this is the calculation. Does the order of operations matter here?
Yes.
Well, yeah. What the answer to that is always yes, by the way. But do we need to use parentheses here?
No.
No. Multiplication and division are technically on the same level. So whether we divide time by distance first or multiply distance times 1,600, we'll still end up with the same answer. That's kind of the point, right? All right, so there's our calculated property. Now we just need to prove that it works. So let's do that part. So let's do var, let's call it a run. And then we'll pull up our running workout with distance, time, and elevation. I'm going to put in 5,000 meters for distance with 1,200 seconds. And we did an elevation change of 13 meters. Right now we're going to just do a print. And what are we going to do? We're going to take that run and we're going to print the average mile time. Once again, notice no parentheses here because it's a computed property. So our average mile time is 384 seconds per mile, right? And of course, you could divide the 384 by 60 and figure out how many minutes it's taking them, right? It's not a world record pace for sure, but it's not that bad. All right, so that would be the solution for that one. All right, let's keep scrolling down the page here. In other app exercises, you've provided encouraging messages to the user based on how many steps they've completed. A great place to check whether or not you should display something to the user is in the property observer. All right, and now we're going to introduce this. We did a did set, and then now we're going to do what we call a will set, right? So in the steps structs below, add a will set to the steps property that will check if the new value is equal to goal. And if it is, prints a congratulatory message. Create an instance and it gives us the numbers and let's see if it works, basically. All right, so here we are with the steps struct, and you can see we have steps and goals. Then we have our mutating function where people can take a step, so it'll keep increasing them. But what we're going to do here is we're going to improve the steps property with a will set. So we're adding curly brackets, then we'll use the keywords will set. And once again, curlies. And now we're just going to check. We're going to do a check. We're going to say if the new value is equivalent to goal, then we're just going to say, hey, you did it, basically. You know, I mean, you can get more verbose than that, I suppose. You can say, congrats. I'm abbreviating. You met your goal. Something like that. Okay. We were only asked to put that on that particular one, right? Now we got to test this and see if it works. So once again, let's run the variable called steps, lowercase, and we will create a copy of structs, uppercase, with steps and goals. And the numbers that the author was using was 99.99 for steps. And then the goal is 10,000, meaning they're just short of the goal, right? However, they're one step short. So we're gonna do that steps and we're gonna take a step to get it up to 10,000. Right. And then we'll take a look at the console there. And notice what's happening here is the computed property is what's putting the message on the screen. Right? So rather than having a method that we're calling, what's happening is every time we're changing the value, and you know what? Every time they take a step, it's going to be adding to it. Now we're not seeing the result of the calculation, right? But we certainly have met the goal for the day. But here's a way that you can test it, right? So if I set this to 997, right now it should say nothing because we haven't met the goal, right? And the moment I take one more step, that should put me up to 10,000. And there's you met your goal. Now, of course, that if statement could have an else that says not quite there yet, you know, or you could get it more complex than that. But really what all they're looking at here is they want the positive message of you met the goal if you hit that threshold. So that, I think that one's working just fine. You guys good?
Yep.
Okay. I'm going to keep pressing ahead here. I want to finish off this playground before we take a break. So getting there. Next one is type properties and methods. So this one says, imagine you have an app that requires the user to log in. You may have a user struct similar to that shown below. However, in addition to keeping track of specific user information, you might want to have a way of knowing who the current logged in user is. Create a current user type property on the user struct below and assign it to a user object representing you. Now you can access the current user through the user struct and print out the properties of the current user. So right now we have these basics in place, right? And there's a little bit of like reading between the lines you have to do here to really understand what they're saying. Like if I read it and maybe you read it again, or maybe you read it in your mind just now and you think you heard what they want, but I think a lot of people miss kind of their point on this one. It could be, I think, maybe stated more clearly. So here's an example of when I might actually want to change the markup on this playground, because I think it could be a little bit more clear. Now, this is where it gets kind of interesting. So they're placing in here these basics, right? But it says, keeping track of specific user information, you might want to have a way of knowing who the current logged in user is. So they want us to create a user type property and assign it to a user object representing you. All right, so let's see if you guys are with me on this. So let's create another property, and I'm going to add the property to the top. And then I'm also going to add a keyword here static to the mix. And I don't want to get like deep into explaining what that means, but static basically means that it's in a sense, not that it's not mutating, but that it's not going to change relative to the object as the object is executing is really probably a good way to say it. So we're going to create a var here called current user. And this is where it gets interesting. So this is a property, right? Normally it would be like a string, a double, an integer, a float, or, you know, like one of those kind of data types. But here we have the capability of making this property basically self-referencing. So like, check this out. We're gonna, what kind of user is it? Well, they're a user, right? Which is basically the user constructed with a username, email, and whatever. So for example, they might have a username with an email of, I don't know, I'm making this stuff up sort of. And their age is, of course, like, you know, really, well, it's a robot, right? It's 2 years old. Probably has, you know, at 24 years, a robot would probably be scrapped, right? Like our cars would be. All right. Next thing that they want us to do is also create a function, right? And let's read this really carefully. Create the current user type property on the user struct below and assign it to a user object representing you. Well, I'm not RoboCop, but you can, whatever. Now you can access the current user through the user struct. And let me kind of just demonstrate that piece of it. So let's do that part first. So let's do a print. So if I call the user current user dot username, right? So we're really kind of like expanding our dot notation here. I don't know if you guys are kind of picking up on the little secret sauce here, but notice in the sidebar on the right that it is picking that up. So I'm not going in there and setting the values because the values are already set internally. Okay. So
And then this is something that we can't change, right? So if we wanted to switch
correct.
the name, the user's name, you can't because it's hard coded as a static.
Well, right. And you think about that. If somebody logs in as a user, well, that's the user it is. You want to be a different
Right.
log out.
Okay. Yeah.
Right? You know what I mean? So, and that's kind of the why behind it. But what we're showing here is that you can extract all the information from it to prove that it's there. And that's really what's happening here is we're calling the struct, we're calling one of the properties inside that also has a property. So it's a property of a property. It's really, I mean, if you want to really kind of boil it down to that, that's really kind of what's going on here. So we can pull back all 3 pieces of information, right? And our robot is only 2 years old. All right. Okay, so as I scroll down here, and I'll try to keep all the code in view, it says there's other properties and acts associated with the user that might be good candidates for a type of property or method. One might be a method for logging in. So go back and create a type method called login user. So notice that we're gonna like put the user into the mix here, where user is of type user, right? Just kind of like what we did above. In the body of the method, assign the passed in user to the current user property and print a statement that the user has logged in. So let's give that a try. So first we have to come up here and we have to add another method. You can put it really anywhere you want. Where the author placed it was here, which I thought was a little weird because I usually, you know, typically like this stuff at the top, but that's not how he's doing it here. So I'm following his pattern, not one that I would use. I'm just putting it out there. This one we're going to call login. And we're going to log in with a user, which is of type user, right? So the data type. So this is also showing you that once you build a struct, it becomes like what we call a reference data type, and then you can use it in your code. So in this spot here, inside these parentheses, really what we're moving around is not an integer or a string. We're moving an entire user object with the username, email, age, current user, and login capability all built in. All that travels with it. So that's what that means when we put it there. Now, what we're going to do inside here is we're going to say that the current user equals user. Okay, the one that we're passing in because we're changing it, right? Then we're going to put a message on the screen and we're going to say print. There's my double quotes, a little string interpolation here. Then we'll say the current user dot username, that's what we're checking, is now like that. Now we have to write a little bit of code to test this. So I'm going to come back down now. I'll leave that in view. And then down here, let's test it all out and make sure that it works. So let's create a constant. We're just going to call this new user. We're going to call the struct all of its stuff, and you can call it Joe whatever with his email JW at Gmail. How about something like that? An age of now we're going to take that struct, we're going to call in that method, and which one are we sending in? The new user that we just created. Now, if you look at the output at the bottom, it shows that it did change it. Now, Joe whatever is now logged in. So that should be the correct output here if you got it to work right. You guys good? And there's all the code on the screen at the same time.
Yep, I'm good.
All right, excellent. Let's move on to the last one. This will be our last page of this playground. And I think a good way to proceed on this is let's do the kind of like the maybe the challenge approach on this one. So why don't we pause the recording? Let's take a 5 to 10 minute break. Those of you here in the session, you guys can work together if you wish, but I'm going to mute myself, stop the recording, and see if you guys can come up with a solution to this. Then we'll double check it and see how you did. I think that's a good way to proceed. So we are on the last slide here of this playground, but the recording is being paused at least for a few minutes, and I'll give you guys about 10 to work on this, get as far as you can, and then we'll resume.
Okay.
Okay, we're back from break, and I had put forth the challenge to everybody to try to figure out this exercise. And basically what they're having us do here is, well, let's read it. I think that's probably easier than me trying to explain it. Once again, the fitness tracking app, and it says we already added a computed property with the average mile time from the run. However, you might want to have a calculator of sorts that users can use before the run to find out what mile time they need to average in order to run a given distance in a given time. This could be helpful to have a type of method on running workout that can be accessed without having an instance of running workout. Okay, that's a really convoluted explanation for I think what they're trying to say here. It said this method should have a return value of type double, right? So this is going to be a method with a return. And the body of the method should calculate the average mile time needed to cover the passed in distance in the passed in time. So assume that the distance is in meters and 1 mile is 1,600 meters. So same calculation. And when it comes right down to it, this isn't really a lot different than what we did before. It's just the approach is a little bit different. Okay. And I want you to watch the things that I'm going to add here. We're going to go back to like adding the static keyword on this, on the stuff that we're adding. We have our 3 existing properties and those are going to stay, but now we're going to add a couple of things here. All right. And first we're going to start with that method that they're talking about. So I am adding this at the top. This is going to be a static method, by the way. So we're going to start with that keyword static, and it's a function, right? And we're going to call this mile time for, and parentheses and curlies. Now I'm going to go back to the parentheses here and populate in the things that we need. And what we're going to put in here is basically 2 of the fields. We were told, if you're going to calculate this aspect, you really need to have the distance and the time to do the math, basically. Distances of type double and time is of type double. We were also told that this will return a value of double. And then we're going to go directly to the math. And the math is the same math we did before. So time divided by distance multiplied by 1,600, or roughly a mile. Right, so there's that piece. Now, to test that this works, at least at this point, we're just going to do a really simple print. Yes, I'm pasting this in for the sake of time efficiency here. So that's what so we're going to call in the running workout, the mile time for with that distance and time. And I want you to notice what the difference is with this. We are not creating an instance of the structure, but we're calling in an aspect of the structure and its capability. We're calling its method that we're going to use to do the calculation, even if we don't create a structure that contains the data. We can still pass it the data, have it do the math, and have it return it. That's what the 360 is. So this is kind of like a non-constructed object, but we're using like the object method to do the calculation rather than recreate it. And we do this kind of stuff all the time in programming and we don't think about it, but this is not getting stored in memory, but we are managing to basically use this structure, and more specifically this method, which accepts those 2 values and returns a double. And that's why we're getting 360.0 here. So kind of an interesting approach. Right. It also tells you that if you have a structure, you don't have to make a copy of it in memory. Now, the same thing is going to happen down here, but notice it says it may be helpful to have a few type properties on running workout representing unit conversions. So for example, meters to mile, feet to meters, etc. So it says go back and add a type property for meter and feet and give it that certain value, and then a type property for miles and meters and give it that value, and then print the values below, right? So and this is just to show you that once again, we can pull the data out without actually creating the object in memory. That's the grand goal. In the structure, we'll start up at the top by adding basically 2 static variables. Now, just to give you clarity on this, one of the reasons this works is because of that static keyword, meaning that we can run this and access it without changing it externally and without creating the object, so there's a whole bunch of different subtle meanings here. if it's not resonating in your brain what the static thing means right now, I wouldn't worry about it, except to know that it's necessary here for what we're doing, you know, and maybe that's enough for now, you know. All right, so is that the right value? No, 8084. Right, that's meter and feet. And then let's add another one that we were told to add, and this one would be mile in. So, and then that's 1600, right? We know that one now, but we're gonna make it a double by putting a 0.0 after it. All right, we're not doing anything fancier with these right now. The point really is this, that you can create these things in your structure and then just call them dynamically and return the values. We're not necessarily using them for anything. The point is that we're able to create them and access them without creating a variable version of the structure or a constant version of the structure, but the contents inside that structure, or at least the format for the structure, is accessible. So there is that one complete. That's all of it. All right, I'm going to stop the recording here. So that finishes off this playground.